Hello all, welcome to my YouTube channel. Today we shall do hypothesis testing for single mean using t-test. Okay, so let me read out the question first. The average weekly production of employees of a company was 20. A recent survey of 10 employees gives a mean production of 20.54 and standard deviation 2.2725. It may be assumed that weekly production follows normal distribution. There are two parts of the question. First part, at 5% level of significance, is there sufficient evidence that the weekly production has changed? And part 2 is, at 1% level of significance, is there sufficient evidence that weekly production has increased? Okay, so first we shall understand why we are doing t-test. Okay, so this is a hypothesis testing for mean. Mu, population mean mu, because we want to see whether the mean has increased or mean has changed, mean weekly production of each employee. Okay, so this is a test for mean. And let us see the sample size, n equal to 10. Sample of 10 employees, n equal to 10. This is a small sample, less than 30. So, small sample test, and also the sample standard deviation and sample mean are given. So, sample standard deviation is 2.2725. That is given. So, we see that population standard deviation is not known to us. Okay. So, this is a test for mean for a small sample size, and also population standard deviation is not given, but sample standard deviation is given. In that case, the test appropriate is t-test. Why not z-test? Because we know that for mean we can use z-test. Okay. For z-test, the sample size should be greater than 30 and population standard deviation should be known. Okay. Even if sample size is more than 30 and this is not known, that we cannot use z-test. Okay. So, for z-test, these two criteria must be satisfied, that is n greater than 30 and sigma no. Okay. Since these two conditions are not satisfied, we can use the alternative test, that is t-test, which is a small sample test. Okay. So, one more thing is that for small sample we can use t-test only if the population is normally distributed. That is mentioned in the question. See, it may be assumed that the weekly production follows normal distribution. Then only we can do t-test because the sample size is small. If the sample size is large, n is large, then we can use t-test even if the population distribution is not known to us. It may be normal, it may be a skewed distribution, but we can use t-test if n, the sample size, is large. Okay. So, we need to understand that this is a test for mean, this is a small sample test, and also sample standard deviation is provided, population standard deviation is not provided. So, appropriate test is t-test. Okay. Now, we go to the various steps of hypothesis testing one by one. Okay. The first thing is that there are two parts of the question. So, we shall do the first part, okay, first, and then we go to the second part. Okay. And one more thing, for both the parts we shall do the t-test in two ways. One is conventional method. What is conventional method? In conventional method, we find out the critical value and compare the test statistic with the critical value. Okay. And there is another method which is p-value approach, that we find out the p-value and then we compare with the level of significance. Okay. So, we shall do both of them one by one. Okay, so the first step of hypothesis testing is setting up the null and alternative hypothesis. Okay, so what is null hypothesis? It is given by H naught. Okay, and null hypothesis is the hypothesis of no difference. That means in the null hypothesis we state that mu has not changed from the previous mean, that is 20. Mu is not different from 20. Okay, so this is the null hypothesis, and the alternative hypothesis is that denies the null hypothesis. So here we state that, what is the question? At 5% level of significance, is there sufficient evidence that weekly production has changed? See the question, it has changed. So we have to test whether mu has changed or not. It is not mentioned whether mu has decreased or mu has increased. So when it is not mentioned, then when it is only changed, we put the not equal to sign. That is, mu equal to 20 is the null hypothesis, mu not equal to 20 is the alternative hypothesis. Now what type of test is this? When the alternative hypothesis has this not equal to sign, that means the alternative hypothesis is two directional. Okay, and the test is called two-tailed test. Okay, so we shall do a two-tailed test for mean. Step 2 is the finding out the value of test statistic. We know that we are using t statistic here. So the formula is t equal to x bar minus mu divided by s by square root of n. Okay. So we put the values from the question. X bar is the sample mean, and a sample of 20 employees give mean 20.54. And mu is the hypothetical mean, that is 20. S is the sample standard deviation given to be 2.2725 divided by square root of n, that is sample size. Okay. Calculating this, we get the value as 0.75. Now we go to step 3, the decision rule. Okay. So the decision rule in conventional method, we have to take few things in mind. First thing is that what is the level of significance? The level of significance is alpha equal to 0.05. 5% level of significance means alpha equal to 0.05, and then we have to find out degrees of freedom. That is important part in t-test, degrees of freedom, because the t distribution depends on the degrees of freedom, and that is given by df. Okay, and how we calculate degrees of freedom for one sample t-test? That is n minus 1. N is the sample size, so n minus 1, that is 10 minus 1 equal to 9. So we got level of significance 0.05 and degrees of freedom is 9. Also the test is two-tailed test. Okay, so for level of significance alpha equal to 0.05, if it is two-tailed test, then what we do, we divide alpha by 2. That means the critical region will be at the both tail. Okay, and the area for the critical region is 0.025. Okay, so for two-tailed test, the critical region will be at the two tail of the t distribution curve. Okay, and this alpha 0.05 is divided into two parts, 0.025 this side and 0.025 in the right hand side. Okay, and we have to find out this value of critical value of t, 0.025 minus 0.025 t plus 0.025, that will be the critical value of t. So we find out the critical values of t from t distribution table for alpha equal to 0.025 and degrees of freedom 9. Okay, how we get these, find out these values of critical values of t, I shall show you in the later part of this video. Okay, so for now we know that the critical value is 2.262, that is this side is negative 2.262 and in the right side it is positive 2.262. Since t is symmetrical about 0, okay, therefore the left and right side critical values will be same, only the sign will be different. Okay, so now the decision rule. So when we reject the null hypothesis, we reject the null hypothesis if our calculated value of t mod t is greater than modulus t greater than 2.262. Okay, that means t can be, if t is greater than positive 2.262 or t is less than negative 262, we reject the null hypothesis. So this is our decision rule. Now we go to step 4, that is decision. So our calculated value of t was 0.75 and we can clearly see that this is not lying in the rejection region, because the rejection region is here and this t is lying somewhere here 0.75. Okay, so this is not in the rejection region, this is in the acceptance region. Okay, so since t is less than 2.262, we fail to reject the null hypothesis. And then we go to the final step, that is conclusion. So step 5 is conclusion. There is not sufficient evidence to conclude that weekly production has changed. Since we could not reject the null hypothesis mu equal to 20, we cannot say that the weekly production has changed. So final conclusion is written like this: there is not sufficient evidence to conclude that weekly production has changed. Now we shall do this problem with the p-value method. Okay. For p-value method, the step 1 and step 2 are same. Step 1 and step 2 are same. We state the null and alternative hypothesis, then we calculate the value of test statistic. Step 3 will be calculation of p-value. So calculation of p-value, p-value is given by probability modulus of t greater than the value of test statistic. That means since this is a two-tailed test, p-value will also be at the both tail. So whatever be the value of test statistic, it is 0.75. So we have to find out the area greater than 0.75 in the right side and area less than 0.75 in the left side. Okay, so combining these two is our final p-value. Okay, so for t statistic, p-value calculation manually is not possible or not possible from the t table. Okay, so we can find out the p-value with the help of Excel. Okay, so there is a Excel function. I will show you how to calculate the p-value using Excel later in this later part of this video. Okay, for now I am just telling you the what will be the value of p-value. From Excel, using Excel formula, the p-value is 0.4724, and for your record you can write down the formula. It is equal to t dot distribution dist dot 2t 0.75, it is the value of the test statistic, and then comma the degrees of freedom is 9. So if you put this formula in your Excel, you will get the p-value 0.4724. That is t distribution, 2t, that means 2 tail, and this is the value of test statistic, and this is degrees of freedom. After we find out the p-value, we go to decision. Okay, so how we take the decision? We compare the p-value with the level of significance. This is the difference between the conventional method and p-value approach. Okay, so p-value is compared with alpha. So if p-value is less than alpha, the level of significance, we reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. So in conventional method, we compare the test statistic value and critical value. But in p-value method, we compare the p-value with the level of significance. Here our level of significance is 0.05 and p-value is 0.4724. We can clearly see that p-value is greater than 0.05. So our final decision will be fail to reject the null hypothesis. Okay. So now we go to final step. Since we have failed to reject the null hypothesis that mu equal to 20, that is, we cannot say that mu has changed. So there is not sufficient evidence to conclude that weekly production has changed. This is the conclusion. be greater than the test statistic value. Since this is right tail test, only p value will be at the right tail only. Okay. So suppose this is the t distribution curve and this is 0.75. So p value will be here. This is p value. And we also know that we cannot calculate p value using t table or manually for t distribution. So we shall use Excel or any other software to calculate the p value. From Excel formula, the p value is found out to be 0.2362. I have shared the formula for p value using Excel. T dot distribution dot rt in bracket 0.75, that is value of test statistic, comma the degrees of freedom, that is 9. Okay. Using this you can calculate the p value for right tailed t test. Now step 4 is decision. So how we take decision in case of p value approach? In p value approach, we compare the p value with the level of significance, that is alpha. Okay, here alpha equal to 0.01 and p value is 0.2362. So clearly p value is much greater than alpha. Therefore, we fail to reject the null hypothesis. Remember, p value has to be less than alpha for rejecting a null hypothesis always. Okay. Since here p value is greater than alpha, we fail to reject the null hypothesis. Then we go to the final conclusion. The final conclusion is that there is not sufficient evidence to conclude that weekly production has increased. Okay. So remember, whether you do in conventional method or p value approach, your decision and conclusion are coming out to be same. Now I shall show you how to find out the critical value of t from this t distribution table. See, this is a t table, okay, and these are probabilities given, that is level of significance, one tail and for both two tail, and this column is for degrees of freedom. Okay, this first column is df and this thing. So for the first part of the question, our level of significance was 0.05 for two tail, or we can say 0.025 for one tail, anyone you can choose, and degrees of freedom was 9. So we select the row for 9 degrees of freedom and select the column for alpha equal to 0.05. The intersecting cell is 2.262. So this was our critical value of t for alpha equal to 0.05 and 9 degrees of freedom, two tail critical value of t. Okay. For the second part of the problem, the level of significance was 1%, that is 0.01, and that is for one tail test. So see 0.01, one tail. See, find out one tail and corresponding level of significance 0.01, degrees of freedom is same 9. So we choose the row for 9 degrees of freedom and choose the column for 0.01. The intersecting cell is 2.821. Okay. So this is the critical value of t for one tail test, alpha equal to 0.01 and 9 degrees of freedom. How to calculate the p value using Excel? I can show you using this Excel function, that is, put a equal sign in any of the cell, then t dot distribution dot two tail, put a bracket, write down the calculated value of test statistic, comma the degrees of freedom. So this is the two tail p value. For one tail p value, equal sign t distribution dot right tail, the test statistic value, comma, the degrees of freedom 0.2362. So this is how you can easily calculate the p value using Excel.